Good morning, everyone. Today's lecture is about the drill string design. And first of all, I want to ask you, what is drill string? So far, most of you should know what is drill string. Can anyone tell me what is drill string and can define it properly? This drill string, what is this drill string?
So it's the pipes that go into the well and they're connected to provide the weight on the drill bit and the drilling fluid goes through them.
Your voice today is not clear.
Can you hear me?
Yes, I can hear you, but it's slow. Okay. Now we are going to do the drilling process. So the one thing which can connect this derrick with this reservoir through the bit is the drill string. So drill string actually I can make a side hole also. Okay. Now the drill string, as you can see here, this is the drill string. So how we can define it? A long section of pipes which connects Kelly to the bit. It's a long section of pipe starting from this place and at the bit, long section. But this drill string is composed of various different types of pipe. It is basically a section of pipes. All are pipes, a different pipe. Drill string is composed of different pipes. Different pipes. What are those? Drill pipes, drill collars, reamers, and so on. Heavyweight drill pipe, drill pipe, and so on. So we have a number of sections, different kind of pipes connecting from the top to the bottom. Now first let's look at them before we go to the further.
By modern drilling methods greatly increase wear conditions. This wear can exceed API or customer specifications
and greatly limit the working life of pipe and connections. Difficulty in tracing pipe wear complicates long-term maintenance. The conventional hard
To optimize their performance and provide for easier handling, in vertical wells, the basic rule is to keep the drill pipe in tension and transmit weight to the bit by using drill collars and heavy wall drill pipe in the bottom hole assembly. In horizontal wells, the rules are more complex. Transmitting bit weight through the lateral section requires drilling in compression. The weight stack section may be in the vertical portion of the well, with compressive service drill pipe run in the horizontal portion. In the bend section, the pipe has to be able to withstand bending stresses.
So as I said, the drill string composed from this section to the bit. Trying to find the complete one.
To optimize their performance and provide for easier handling, drill collars are available with a number of special features. Fishing necks allow drill collars to be made up to proper torque using drill pipe handling equipment and provide clearance for an overshot and grapple assembly in case fishing becomes necessary. Stepped bores in the pin connection provide for increased strength and small reducing trip time. Spiral grooves help prevent pipe sticking by reducing the wall contact between the collar and the borehole. Other drill.
Let's start with the lecture, and during the lecture we will know. Okay. First of all, let's talk about what is drill string. As I showed you, the drill string is a section of pipe, or you can say it's a section of tubulars and accessories on which the drill bit is run to the bottom of the borehole. And so you can say a section of pipe starting from the galley to the bit. What drill string is made of or consists of? The drill string consists of drill pipes, drill collars, galley, and various small equipments that we have, like stabilizers, reamers, which are included. One of the job of the drilling engineer at site has to design this drill string. Remember, again, we are not drilling 1 feet, 2 feet, or 5 feet. We are dealing here thousands of feet, maybe 10,000 feet, 7,000 feet, 6,000 feet. So it's really long section of pipes that we have to manage as an engineer. So it all comes with the calculations and careful consideration so that it do not break, buckle, collapse, burst, or any kind of problem happens with the drill string. So for now, drill string is a section of pipe. It consists of drill pipe, drill collars, and various other small equipments that we have. Here you see that, look at the bit size, what bit size we have. We have 12 1/4 inch outer diameter. As you know, we have outer diameter of the pipe and inside diameter. And the minus between both of them is the thickness of the wall. But for now, we are considering the outer diameter. So thick outside diameter is 12.14. Remember that the laptop screen you have, it also has a size. You can imagine how outside diameter will be. So 12.5 probably is the size of the screen of my laptop right now at this point. Then, as you know, that drill bit is bigger, but with this, we have a section connected with it, with section of drill collars, reamers, stabilizers, and jars. This assembly's length is around 9.5 inch. So it is smaller than the bit, this drill collar. And the purpose of this bottom hole assembly section is to provide the weight to this bit so that it makes bit heavier so that it can proceed with the drilling. So, and you see that the length of this heavyweight section bottom hole assembly is only 600 feet. The total length probably is 10,000 feet, starting from galley to the bit. But the majority of the section of this drill string is composed of the drill pipes, 9,400 feet. And drill pipes are even outside diameter even smaller, which is the 5-inch outside diameter. Inside diameter, you can say, is around 4.25 or 4.5. Usually 4.5 is used as the inside diameter and 4.5 inches the outside diameter of majority of the length. So for example, from here till the bottom, the length is 10,000 feet. Out of those 10,000 feet, 9,400 feet is the drill pipe. The majority, 95% is drill pipe. Then the rest of it here is the bottom hole assembly, which the major component of this part is the drill collar. Okay. Why we are putting lots of weight in the last section and why we are not putting the weight here? Anyone can answer me, like why, for example, purpose of this section. Let me take this picture. And okay, if you look at okay, I cannot put the picture here. The section which is starts from here till here is 10,000 feet. Now the question is, this section which we are talking about from this point to this point, why we are not putting it on the above side, this section. Remember, there are two functions of these two different sections of pipes. The overall drill string, as I said, is composed of drill pipes and drill collars and so on. Above part is the drill pipe and the lower part is the drill collar, or plus small equipments like reamers, stabilizers and jars. Mainly is collars. Now this part is to provide the weight. Remember the function. This part is just to provide the length to the bit, the drill pipe. So drill pipe, the purpose of drill pipe is just to provide the length to the or section of to the bit so that drill bit can rotate. The other function of this drill pipe also is to provide the way for drilling fluid to go inside the drill string till the bit. This is the second function of this pipe. But this bottom hole assembly, it has one additional function, and what is that? Is that it provides weight on the bit. So the lower portion provides the weight on the bit, the upper portion provides the length of the bit. Now, when we design the drill string, we consider two things important. The above part, for example, if you put lots of weight here, at this point, the pipe can buckle, because this pipe is not that good quality as this drill collar. This collar is very thick, very heavy, very high quality. And if you put lots of weight on this drill pipe can buckle and break at the same point. So what we do, we try to put the weight near to the bit so that this drill string should sustain the weight of this bit as well as it functions properly, and life of this drill pipe also becomes longer. This is the first thing, that why we keep the drill pipe above and drill collar low. Second thing is the above portion, we try to keep it the suspended. We tried the above portion provides the tension in the drill string, just to hanging tension in this pipe. But the lower portion provides the compressive strength to the bit. So it try to compress the bit. So the lower portion provides the compression, the above the part of the drill string provides the tension, and then we have a neutral point where there is no compression, no tension, nothing, or zero forces acting on this point. Remember, when we are talking about the drilling process, drill string, all the hole is filled with the fluids, drilling fluids. Now, buoyancy factor also plays a major role in the drilling fluid here, because when you have the weight in air and when you do the weight inside the water, it's different. Inside the water, it is supported by the liquid also, so it is always lower than in the air. So one of the function of the drilling fluid is to support the weight of this drill string also. And it keeps the above part in tension, the lower part in compression, so that the bit can rotate and we provide the weight. The largest diameter of the drill string is of the bit. If the bit is 12-inch size, definitely you cannot put 15-inch of drill collar. Your pipe will get stuck and you cannot proceed the drilling. Drill pipe, drill collar always have to smaller than the drill string. Now, so for example, there's another point that we can share here. For example, we have the bit which is 12-inch. We always make a bit like this. Let's say it is 12.5 inch. Now, the drill pipe, the outside diameter of the drill pipe is also 5 inch. Now, if you minus 12.5, 12.5 minus 5 is 7.5 inch. So the borehole here where the mud returns is extend to the surface also. Okay. Now the borehole space here is also 7.5 inch. This one is overall is 7.5 inch. That's why the drill pipe size is always smaller than the this bit. Bit, for example, you are using 12.5 drill pipe, you are using 5 inch. Definitely drill collars are bigger as you saw in the table I showed you, and so on. Here it is. Now let's talk about what is the drill pipe function of drill string. As I said, drill string has three functions. Is to first to suspend the bit. It has to suspend the bit. Then it provides the torque rotary motion from the galley to the bit so that bit can rotate and cut it. Second, it provides the way or passage for the circular drilling fluid to goes to the bit and come out and take the cuttings to the surface. Three functions are important for drill string, and we need to be aware. Also remember, as I said, in deep wells, drill string is 5 to 6 miles long. So at least you can assume 10,000 feet. Imagine the roof of our home usually is 12 feet to 14 feet. So when we talk about 7,000 feet, 8,000 feet, it's really a long section of pipes that we have to care as an engineer. As I said, the 90 to 95% of drill string is composed of drill pipes. And it's a pipe, it has some connection, and we call them the tool joints. Okay, it has two kinds of tool joints if I show you in the picture, above part and below part. It has some here pins here so that it can screw up, and then the other section is the pipe. For example, if you are drilling, let's say 3,000 feet, so out of 3,000 feet, each section is 30 feet and 90% is this drill pipe. So we have to connect every 30 feet of section. So we have to make sure that these tool joints has to be very strong. There should be no leakage of drilling fluid, as well as they should not break. For example, sometimes the quality of drilling pipes is not good, so they can break. And if the drill pipe breaks, you must know that you have to then retrieve all of it, change it, then send it back, and then remove whatever the metal part is remaining inside. It's a very costly job, and the cost of per day at rig is $70,000 to $80,000. So if there's something like this happens where the drill pipe is broken or something, and you spend 2 days just to take this section out of it, so you lost a lot of money. So like 150,000 to 200,000 you lost just because your pipe is broken. So make sure you use the right drill pipes, good quality drill pipes, so that they do not break and their joints are strong. That's why we keep the record of these drill pipe and drill collar at the field and site. What is the current condition of this drill pipe and drill collars? We have three ranges. API, American Petroleum Institute, has given us three ranges for this drill pipe: 18 to 22, 27 to 30, 38 to 45. So 27 to 30 is the most common one. What you see in the videos always, you see range 2. So range 2 drill pipes are most commonly used, and this one on the rig side. but they are not uniformly length. Sometimes they are 29, sometimes they are 31, 31.5. But we consider them 30 as one. Now let's look at the different dimension, different kind of drill pipes available. Look at the weight per feet. This is the pound per feet weight. Let's say 5-inch pipe has 515.5 pound per feet. If your section is uh, 30 feet of pipe, so the overall weight will be, let me calculate, 15.5 multiplied by 30. So 465 pounds just for one pipe. The weight of one drill pipe of this one is 465 pounds, which is a lot. So imagine if you have like 3,000 pipes like this one. So the weight is 1.4 million. That's the condition of the pound weight of the drill pipe of long section, which is 3,000 feet. So overall, the weight of this drill string depends on drill pipe plus the drill collar. Drill pipe weight is less, but drill collar is more heavier, more thicker, and it gives, the main purpose of drill collar is to provide the weight. Mostly we use this 5-inch and 15.5, and if there we see that there's chance, we use 16.25 also. And look at the inside diameter. 4.44 is inside diameter, 4.4 inch. So the pipes are really thin, they are not really that big. 4.4 inch, you can imagine how much it will be the diameter of it now. Then we have different qualities of the pipe. We have D, E, X, G, and S. Also, it depends on the stress level they can handle, yield stress or compressive stress. So we have to look at it like how much stress they can handle. We have different kinds of pipe, and we have to select which kind of drill pipe we are going to use to drill this well. And as you know that has this minimum stress, means it has the least quality, S is the highest quality one. And it also depends on the pore pressure and fracture pressure of the formation, which kind of drill pipe we are going to use, because they have to handle those pressures there also at the same time. Okay, then weight of the drill pipe, as I said, inside the pipe, inside the hole where there's full of drilling fluid is different than in air because of the buoyancy. Because buoyancy actually reduces the weight of the drill pipe, and we have a factor, buoyancy factor, we have to calculate. We will do in the next lecture those calculations related to drill pipes. We have to multiply the weight of pipe in air multiply by the buoyancy factor, which is around 0.8, sometimes 0.7. So it reduces the weight of the drill pipe inside the borehole, which is because of the buoyant forces of the drilling fluids happening at the. Now these drill pipes usually the life of those drill pipes, how much they can be used. So you can say that each drill pipe they can go up to 25 to 30 wells. Usually we don't drill 10,000 feet deeps. We usually drill 6,000, 5,000 to 6,000 feet. Also in Kurdistan, 5,000, 6,000 are the normal depths. We can drill up to 25 to 30 wells with the same kind of drill pipe. We don't have to buy drill pipes again and again. They are the part of the rig company. They have the drill pipes already, so they can use it for 25 to 30 well, unless they wear and tear and they damage themselves and so on. As I said, we keep a log for those drill pipes. We make sure that they have enough. Their quality is fine enough to use it, because as I said, if the drill pipe is broken or it is leaked, in order to change it, you need to spend at least 1 day or 1.5 days. Now, in order to do that, you are going to lose a lot of money. So we make sure that no pipe should break down when we talk about the drilling process. We definitely do NDT tests. We check them, the quality. We inspect any defect if they have any cracks, any corrosion, any pits or something. We check them, that what is the current stage of the drill pipes. Then we have like as I say, every mobile phone has the model number. Same like drill pipe also have their classification, like what kind of drill pipe we are using. When you are talking about the drilling company drill pipes, you will see the model written like this one. This one. The first drill pipe could be, so for example, in an exam I give you this one, you should be able to crack this one. What does it mean? For example, when I talk about the first one, first letter, it talks about the outside diameter. What is the outside diameter of the body? It is 5 inch, 6 inch, 4 inch, 3 inch. Range 2 means, as I showed you, ranges already. There are three ranges, API 1, 2, 3. Range 2 means the length is around 30 feet. This is the second one. Third one is the quality, how much it can handle, the stresses. So G95 is the good quality, 105,000. And then how much is the weight of this drill pipe per feet? So it's 19.5 per feet, pound per feet is the weight of this drill pipe we are talking about. And is it used or new? So here is written new. So every drill pipe has its own model number, and based on the model number, you tell them what is the current specification. It's the same like how much is the processor of your laptop, how much is the RAM, and the specifications of the drill pipe. Likewise, these are the specifications we mentioned on the drill pipe. For EXGS, four different kinds of drill grades are available. Mostly we use the E or X because they are cheaper to use. Then you can see they have the tool joints. Here are the tool joints are located at each of the length of drill pipe, and the purpose is to connect all of those pipes. When we are drilling, let's say 3,000 feet down, we have to connect lots of drill pipes together, and we make sure that these joints are well made, these one, and they do not break. If they break, then it's a problem. So we have two kind of tool joints here, pin and box, and they are screwed together at the surface by the roughnecks and drillers assistants there. They do the connections there at the top, and when they are connected, we proceed with the drilling further, and we make sure that there is a proper dope and so on. Now we have different, again, this is a different kind of drill pipes, and different kind of tool joints are available. Okay, NC46 4-inch IF, NC50, these are the most common one. NC50, so this one for example, this one are the most common of drill joints available we have here, and for their threads and so on. So this was for the drill pipe. Drill pipe is function of the drill pipe is to provide the length and the connectivity to the drill bit. Then we have another section, which is the heavyweight drill pipe. The heavyweight drill pipes also provide the length, but their wall thickness is greater than the drill pipe, and they are a bit thicker and more heavier than the drill pipe. Why we use the heavyweight drill pipe? We use at the points where the stress level is a bit higher, and there's a big chance that drill pipe will collapse or will break. So at that point, we use this heavyweight drill pipe. And rotation and cutting action of the bit can frequently result in a vertical bouncing effect. Now, I can tell you from the picture that, for example, when we talk about the drill string, the first section is drill pipes. The second section and then we have the third section. One section, then we have second section, and then we have the third section. This overall is called the drill string. The first we have the drill pipes. The secondly we have heavyweight drill pipe, and third section we have drill collars. Now these heavyweight drill pipes, sometimes they are used as the transition between drill pipe and drill collar, because as you know that drill pipe is 5 inch, is quite less, it has less weight, and on the other side drill collar is very thick, it has higher outside diameter as well as it is very heavier than the drill pipe. So if we connect both of them, there's a big chance that the thread or joint of drill pipe can fail. So what we do in this case, when drill pipe is uh, too thinner and drill collar is too thick, and we use the transition pipes, which call them heavyweight drill pipe, and they are used as a transition between drill pipe and drill collar purpose, so that if there is any stress is happening, or we transfer the stress from drill pipe to drill collar in a small with the small changes smoothly, so that no section of pipe should break at this point. So that's one of the major function of heavyweight drill pipe. It has greater wall thickness, it has more weight, and it is used as a transition because there's a chance that the high stress can break the drill pipe and drill collar connection at the same point. They are always operated in compression. They provide compressive strength to the bit compression. And as I said, drill pipe provides the tension. The heavyweight drill pipe or drill collars, they provide the compression of the drill pipe. So here are the heavyweight drill pipe. The difference between the heavyweight drill pipe and the other one is the wall thickness and the length of the tool joint. The length of this pipe is bigger than the drill pipes here. These are ready to be used. Then the third pipe section that we use are the drill collars. Now the drill collars have much larger diameter. The purpose of this one is not to provide the length. Length is always can be provided by drill pipe, which is cheaper to use. But this one is used to provide the weight on the bit. So its weight is much higher than the drill pipes. They have much thicker wall thickness, and they provide enough weight on bit for efficient drilling. They keep the drill string in tension and reducing the buckling or bending or failure due to fatigue and stiffness provide. They have much larger wall thickness, and their tool joints are can be thread directly into the body. Let me show you. But the difference between the drill pipe and drill collar is that you see that the pipe here is smooth. It do not have the grooves or spiral shape, but this one has the spiral shape. Here, this one. And the purpose is that so that when it is, because it has the higher outer diameter, it can get stuck with the wall of the borehole, and if it gets stuck, it can cause lots of friction there and it can get stuck there. So what we do, we keep some space there so that it directly do not connect to the wall 100%. So we reduce its connectivity with the wall by using those small grooves and so on, or you can say the contact area. We prevent it to prevent the 100% contact area of the drill collar with the pipe, so that it reduces the friction and drill collar can be easily used. As I said, drill collar is the after the bit, the highest outside diameter is of the drill collar, and after that is the drill pipe, and so on. Now I show you the drill collars videos and types before we go ahead.
يصير درسنا ان شاء الله محزم على التول جوينت classification paint bond for drill pipe and tool joint. هنا يعني يقصد لانه تصميم في ال
I'm trying to find the I want to see the picture of the
He looks like he's got a dirty diaper.
Be honest, do you really want to watch a video that looks like this? There's a good reason why presenters use images and visualizations all the time, because it's what makes people pay attention. With a 2D animation, your audience will pay much more attention than just you speaking to a camera.
akşamda la ulkan film ha. La mito tamanak mito. Çek. كان فيديو هناك فوتوار لنا خليفه ديك الشيء اش دا واه خليفه باي باي انا عطيني باش ما مناقش بکشین تو خواه خواه خبر نده بکشین میتو نسترينا بنيه شلو sen buracı bir şey ha?
Fotomontajda kelime iki ayağını gösterme. Ben yanlış yapıyorum. Hoş olmaz. Yani iki ayağını yok et.
Ayaklar.
İki ayağını iki ayak.
Tamamdır. Evet. Al tamam. Tamam. 8 dakika. Bas. Çekme. O zaman o tarafa. Böyle loksiyonu bir güzel çekelim bakalım.
Çek. Kaynakçı.
Neredeyim lan kaynakçı?
To optimize their performance and provide for easier handling.
Now, these are the drill collars which has a spiral grooves as we discussed earlier. These are the drill pipes which are plain in length.
Drill collars are available with a number of special features. Fishing necks allow drill collars to be made up to proper torque using drill pipe handling equipment and provide clearance for an overshot and grapple assembly in case fishing becomes necessary. Stepped bores in the pin connection provide for increased strength in small to medium-sized collars. Slip and elevator recesses eliminate the need for safety clamps and lift subs, thereby reducing trip time. Spiral grooves help prevent pipe sticking by reducing the wall contact between the collar and the borehole. Other drill collar features include tungsten carbide hard facing and gall-resistant coatings. Most of the drill string consists of seamless wrought steel lengths or joints of drill pipe. A typical drill string containing thousands of feet of drill pipe may contain only a few hundred feet of other downhole tools. Because of its greater length in comparison to other tools in the string, drill pipe needs to be relatively flexible and lightweight. At the same time, the top joints of drill pipe must be strong enough to support the entire weight of the drill string. The bottom hole assembly includes all of the tools below the drill pipe and above the drill bit. These tools promote drilling objectives in a number of ways. Drill collars maintain tension on the drill pipe, provide weight to the drill bit, and stabilize the bit as it turns. Heavy-walled drill pipe helps prevent drill pipe fatigue failures by providing a smooth transition between the drill pipe and the drill collars.
As I said, the heavyweight drill pipes, they provide a smooth transition from drill pipes to drill collars. So they are used in between drill pipe and drill collars.
It also aids in directional control. Stabilizers help centralize the drill collars, maintain full gauge hole diameter, and depending on their placement in the string, work to drop, build, or maintain hole angle. Jars provide a means of freeing stuck pipe.
These are the jars.
Rotary reamers prevent bit gauge wear and help ensure a full-size hole diameter. Crossover subs link tools having different types of end connections, and vibration dampeners, when properly applied, absorb vibration and shock loads produced by the bit to keep them from being transmitted up the drill string.
Okay, then we have another equipment. After drill pipes, heavyweight drill pipe, drill collars, we have another equipment. We call it as stabilizers. Now these stabilizers, they are used just above the bit. So we have at the top, if you look from the top, we have drill pipe, then we have drill collar, then we have stabilizer, then we have bit. And if you start from the bottom to the top, then first we have the bit, then we have the stabilizer, then we have drill collars, and then we have. The purpose is of these stabilizers to reduce the vibrations of the bit. So because as you know, you can say it works as a vibration damper also. and also it keeps it in a central position, this one, because in the middle it has this kind of one. It do not let the pipe to go on the side of the wall. It try to keep the bit in the center of the hole at the same time. Okay, this is the function of stress. So it reduces the buckling and bending stress on the drill collars, and it allows the higher weight on bit. It reduces the wobbling effect, as I said, the vibrational effect on the bit, so that bit can perform well. So all the weight on bit is properly transmitted to the bit using these stabilizers. And of course, because of the spiral, these small spiral section, it do not let the drill string to stick to the wall. So it prevents wall sticking at the same time. And it is always placed at the top of the collar. It provides a good place for drill collars to be connected with the bit. So between the drill collar and the bit, we have a small equipment, and it's not too big size, the small size, as you see there. Then we have the reamers. The reamer have these cutters here. They have the blades. The purpose is to keep the hole in the same length, same diameter. So for example, if bit is, some of the part is still remaining on the side of the ball, so this reamer actually keeps the diameter of the hole in a uniform shape. If anything happens or any side wall is still remaining or hole is deviated, so this one will cut it and keep the hole in a smooth inside diameter of the borehole. So the purpose of this one is to keep the whole borehole in the similar diameter from top to the bottom, and that's the function of. Then we have the shock subs. It has the shocks also, drill string. Sometimes because we are doing a lot of rotation to the bed, weight on the bed, there's a chance of buckling and bending. So we have some shock subs also. The provide is to reduce the stress due to bouncing of the bit. Sometimes this bit bounce back. So if we have the shocks like a car, so it will reduce the effect on all the drill strings. So we use the shock subs also, we use the reamers also, we use the stabilizer. They are all the part of the assembly. And sometimes we have different kind of pipe. For example, now you want to join, let's say, drill collar and drill pipe. There is a place you have to join the drill collar. Both have different dimension. For example, drill pipe is 5-inch outside diameter, drill collar probably is 9-inch outside diameter. This inside diameter probably is 4.6. The drill collar's inside diameter probably is 5-inch. So how to connect two different pipes? When you connect two different pipes, you need a drill subs. And purpose is to join two different inside diameter pipes and so on. Then we have the jars, and purpose of jars is to if the drill pipe gets stuck and you have to give a shock or some vibration to the drill string so that it comes out. So jars are activated. It like a hammering effect. They give a hammering effect so that drill string can be free from any sticking or stucking. And this is the purpose of the drill string. Let me show you these one again. They are mentioned here.
Most of the drill string consists of seamless wrought steel lengths or joints of drill pipe. A typical drill string containing thousands of feet of drill pipe may contain only a few hundred feet of other downhole tools. Because of its greater length in comparison to other tools in the string, drill pipe needs to be relatively flexible and lightweight. At the same time, the top joints of drill pipe must be strong enough to support the entire weight of the drill string. The bottom hole assembly includes all of the tools below the drill pipe and above the drill bit. These tools promote drilling objectives in a number of ways. Drill collars maintain tension on the drill pipe, provide weight to the drill bit, and stabilize the bit as it turns. Heavy-walled drill pipe helps prevent drill pipe fatigue failures by providing a smooth transition between the drill pipe and the drill collars. It also aids in directional control. Stabilizers help centralize the drill.
This is the stabilizers, and they have the blades like this one. This is just above the bit. So this lower part is connected with the bit. One of the part is connected with the drill collar.
Collars maintain full gauge hole diameter and, depending on their placement in the string, work to drop, build, or maintain hole angle. Jars provide a means of.
Now these are the jars. As I said, jars provide the hammering effect. So if drill pipe is stuck, they just do the hammering effect in order to free the drill.
Freeing stuck pipe. Rotary reamers prevent bit gauge wear and help.
Then another equipment, as I showed you, is the reamer. Reamer has these kind of blades. They keep the hole diameter.
Ensure a full-size hole diameter. Crossover subs link tools having different.
The crossover subs, they have two different kind of inside diameters, and the purpose is to connect to different
types of end connections, and vibration dampeners, when properly applied, absorb vibration and shock loads produced by the bit and keep them from being transmitted up the drill string.
Okay. Now, these were the components of the drill string. Now we will go for the drill string design. When we are talking about one of the job of the drilling engineer to do the designing of the drill string. How we do that? There are 4 basic requirements. First, you have to calculate the burst, collapse, and tensile strength of the drill string. We have to know at what pressure it can burst, what pressure it can collapse, and what is the tensile strength of them. Then what are the stresses on the drill string going on at the current depth wherever it is drilling? How many drill collars are needed? And what bottom hole assembly must be stabilized to control the direction of the well? We have softwares to do that. Our project one will be to design the drill string. That I will provide you the software that you can use to design the drill string. Okay, but we will do one manual exercise to design the drill string. Remember, this is the most important slide in the drill string design section. First of all, remember the outside diameter can be safely run in the best selection. We have to provide the most weight available to the on the bit. Okay, this is the first thing. Secondly, we want the shortest bottom hole assembly so that reduce handling time at surface, reduce the number of connections, and so on. So weight and stiffness, what size of drill collars you are going to use and how much weight on bit is needed. So weight on bit, you decide the number of drill collars, and that's for that you need a calculation to do that we are going to do that. So bottom hole assembly, as we discussed earlier, is a different bottom hole assembly consists of drill collars, stabilizers, reamers, rollers, jars, and so on. Except drill pipe, all is bottom hole assembly. We should have bottom hole assembly that much. It should provide the weight on bit, necessary weight on bit given to us to do the drilling, and must be sufficient to account for buoyancy factor. Okay, it should be, if you are drilling a vertical well, it should be inclination should be well managed or maintained. So, and also we have to make sure the neutral point of axle load is within the bottom hole assembly and safety factor. Now, this is another most important slide. The drill string assembly can be divided into 3 main parts. One of them is the compression. The above one is the tension, and then there's a neutral point between both of them, which has no force acting on it. Okay, the lower part, which is made of the drill collars and other small stabilizer, reamers, rollers, and jars, and so on. Their function is to provide the compression, and there's a point comes above that we have the drill pipes. So lower part provide the compression, the above part provide the tension. We have to calculate that. We have to keep in our calculations these things in mind, that our purpose is not to just keep in tension, because if the drill string is always only in tension, then you cannot drill process. In order to drill, you have to put the weight on the bit and compress as much as possible so that bit can rotate and do the cuttings, and cuttings can be lifted through the drilling fluid and so on. Okay, then for that, these properties, we will talk about them in the next lecture with the videos. I have a lot of good things, and we will do the designing of drill string the next one, and also I will upload the lecture project on drill string design in a software. So I'll provide you the tutorial how to do the drill string design, and then you have to do that in the software also. So any question from drill string? Any question? Okay, I'm going to upload this lecture, and I think I didn't upload the last lecture also. I will upload both of them. If you have any questions, you can also email me the questions. So that's all for today. Thank you for being here, and have a good day ahead. And see you in the next lecture.
Have a good day, sir.
Have a good day.